video about our summer research project. So for those who have not used MATLAB or have not had any experience with MATLAB before, I suggest you to start from this tutorial classes. So once a YouTube video tells you what MATLAB is, what it can do, and the second link here is for you to learn the environment in MATLAB and some basic concepts. Okay, so it only take you a few hours to go through this interactive tutorial, and this is going to be very helpful later on. Once you are comfortable, you don't have to be comfortable, but just like roughly you can move around in the MATLAB environment, then you can start playing the code I prepared for you. So those are just two examples for you to see what we're going to do. Okay, so because we want to understand what happens when a manifold is being mapped through diffusion maps. So surely the first thing we want to be able to do is to be able to generate a manifold or a surface, let's say. So here I give you an example. I use spherical coordinates to generate dot points on spheres, and I put color on it. So later, when we map these points to a different space, we can see how they are being mapped, which points are being mapped into where. Then we're gonna prepare the code for diffusion maps. And if you read the papers, you can see that we have the unweighted diffusion map algorithm and we have the weighted diffusion map algorithm. So when the points on the manifold are uniformly sampled, so for example, in this sphere that we have here, the points are not uniformly distributed because you can see it's denser here at the North Pole and South Pole and looser around the equator. So this is not uniform sampled points. Okay, so if we have points that is uniformly sampled on the manifold, then the weight alpha equal to 0 will just give you the graph Laplacian that's associated to the Laplace-Beltrami operator. Okay, so we don't care about the density. However, if those points are not uniformly sampled, then choosing alpha equal to 0, you're gonna see the effect of the density function. Okay, so to avoid that, we will choose the weight in this diffusion process algorithms. Here we'll choose alpha equal to 1, and in the paper of Koifman and Lafont, it says that with alpha equal to 1, this graph Laplacian converges to, again, the Laplace-Beltrami operator, and you don't see the effect of the density function. Okay, so that's the first few things that we want to do before we move on to step 3 and step 4. Because step 3, we're gonna generate more examples, more surfaces, and step 4, we're gonna run diffusion map and see what's gonna happen. Okay, so it is very possible that you will run into numerical issues or you will run into errors. So those are totally normal. Just Google is your best friend. So that's the first thing I will do when I run into an error or when I run into a problem. I will try to see like, okay, did this happen to someone else? And I will go from there.